Bronsted Lowery acid-base concept. The Bronsted Lowery acid-base theory, proposed by Johannes Bronsted and Thomas Lowery in 1923, defines acids and bases based on their ability to donate or accept protons, H+ ions. This concept is more general than the Arrhenius definition, as it applies to reactions in both aqueous and non-aqueous solutions.
Definition of acids and bases. Bronsted Lowery. Acid. A substance that donates a proton, H+, to another substance. Bronsted Lowery base. A substance that accepts a proton, H+, from another substance.
In this theory, acids and bases always exist as conjugate pairs, meaning when an acid donates a proton, it forms its conjugate base, and when a base accepts a proton, it forms its conjugate acid. Examples of Bronsted Lowery acid-base reactions. Example 1. HCl and water. HCl, hydrochloric acid, acts as a Bronsted Lowery acid because it donates an H+ ion to water.
H2O, water, acts as a Bronsted Lowery base because it accepts the H+ ion, forming H3O+, hydronium ion.
The conjugate base of HCl is chlorine chloride ion. The conjugate acid of H2O is H3O+. Example 2. Ammonia and water. NH3, ammonia, acts as a Bronsted Lowery base because it accepts an H+ ion from water. H2O, water, acts as a Bronsted Lowery acid because it donates an H+ ion to ammonia. In this example, the conjugate acid of NH3 is NH4+, ammonium ion.
The conjugate base of H2O is O, hydroxide ion.
Conjugate acid-base pairs. A conjugate acid-base pair consists of two substances that differ by only one proton, H+. General rules are as stated here. When an acid loses a proton, it becomes its conjugate base. When a base gains a proton, it becomes its conjugate acid. Advantages of the Bronsted Lowery concept, more general than Arrhenius theory. It applies to non-aqueous solutions and gases, unlike Arrhenius acids and bases, which are limited to aqueous solutions. Explains amphoteric substances. Some substances, like water, can act as both an acid and a base. Applicable to many reactions. It helps explain acid-base reactions in biological systems, industrial chemistry, and even atmospheric chemistry. Key takeaways. The lecture are acids donate H+ ions and bases accept H+ ions. Every acid has a conjugate base, and every base has a conjugate acid. The Bronsted Lowery concept is more versatile than the Arrhenius definition. This concept forms the foundation for acid-base chemistry, making it essential for understanding pH, buffer solutions, and chemical equilibria.